Hey guys, welcome to Inside Out BIM. Today we're going to talk about structural framing and how to make your beams follow the roof and change their rotation so they stay perpendicular to the face of the roof. So we're going to be using a simple but very useful Dynamo script. So yeah, without further ado, let's get on with this. So this is what we're aiming for. This is our goal. So we have a roof and we have beams that follow that roof. Let's go to Revit. So I'm going to show you what I have here. So basically the principle is that usually when you draw a beam, let me just draw a simple beam, right? So you can see what is the caveat with this. You have this one as a straight, right? Our goal is to make our beams always stay perpendicular to that face. So we're doing this with Dynamo. So let me just quickly show you what we can do using Dynamo. So here I have a face of this one, of the roof, and I can change the dimensions, like the length of this one, right? So when I change this, my beams will adapt for this change. And also we can control how many beams we would like to have. So here I have the quantity of beams. So maybe you like to have maybe 25 beams, right? Or 10 beams. It doesn't that matter. So that is flexible. And that is the cool method of achieving actually this effect. So let's go back to the presentation. So what is the challenge? The only challenge that we have is the correct angle for cross-section rotation of a beam. So actually, what do I mean by that? Each beam, if you go to 3D, when you click on a beam, each beam has some sort of a parameter that is called cross-section rotation. So I've deleted this one. So let's draw one more beam, right? So if I go to section, I have a beam that is just going straight, and the cross-section of this one equals to 0. And for each of these beam, we would need to have some angle. For example, if I select the first one, I have here 62.5. So if I change this to 62.5, that will just change that angle, right? So we would need to do for each of that beam that process, and that can be so boring and tedious, right? And if you think about this, but what we can do to get to this part, so we can get this particular angle. So first of all, we just need to understand the way how that would happen using just Revit without Dynamo. So here I have some slides. So for example, this is what we have, default condition, right? As you can see, all of the beams running straight. And here is what we're aiming for. So there are a couple of things that you need to be aware of before starting building a script. So first of all, right, this is what I've just told you, that we have this parameter, cross-section rotation. So with Dynamo, we can get the angle for each of that beam and change that angle. So we would need to go and if we were to do this manually, right, we would need to go and measure the angle for each beam and do this. And in case of update, like if you update your model, you will need to do this over and over again. So doing this manually sucks. So, but you need to also be aware of the fact that, just to show you, it's not the case in that particular one, but be aware of that. If you draw your beam from here to here and from here to here, right, cross sections will be kind of different, right? So if you type here 30, right, oops, and here 30, right, this is the way that works. So basically the angle of this one should equal to minus angle of this one. As you can see, 62.5 and minus 62.5. So yeah, so how we would do this manually. As you can see, this is the logic that I've come up with. So we're having the roof, and we can draw, so let's go to Revit. It's easier to understand here in Revit. So let's draw any line. So I'm gonna go with the shortcut DL for detail line. And when you draw a line, it's going to give you the line that is perpendicular to that face of the roof, right? So that one is perpendicular to this face. And the angle of this one can be just simply drawing a simple straight line and going with dimension. I'm using the shortcut DI for dimension. Oops, use angular dimension. And when you measure, you have something like this, 46.3, right? So that would be the angle for each of this one. So here it's not 46 because we're not measuring actually from here. So that is like the logic. So that is the whole idea and how you would need to approach this. So here I've shown you that the way I will do this in Dynamo, I will actually get this line. So basically the vector that goes in this direction, then the vector that goes in this direction, right? This direction and this one, I will measure the angle, and then I will, to get, actually it's pretty easy to get this angle when you have this one, because the total angle of this one is 90 degrees. So basically what we need to get this 52.92, 55.92. We need to subtract this one from 90 degrees, right? So it's not that complex at all. And now I've shown you here that when I change this cross rotation, I have the correct angle. So that is the logic for the script. We'll have a roof and we'll pick the face, the bottom face, right? And here I've shown, just using some lines, I'm showing you two vectors that we're going to be using to measure, right? For example, the one vector that is the one that is perpendicular to the face. As you can see, all of these vectors are perpendicular to that face. And the second one is just kind of normal from curves. In our case, it's simply like x vector. And that's it, actually. Then we measure the angle between them, right? And then what we're doing is that we're getting isolines. So basically curves along the surface, because this is the way the beams are built. You can always create a beam using a curve, and then you can create this parameter. So let's open up a new project and repeat the same thing, right? So let me go here to Dynamo. I'm gonna close it off, just so we're gonna can build this from scratch, right? Okay, let's go back. Let's go to File, New Project. Let's go with, you'll have like something like architectural template or something like this. I'm using just the default. I've just changed the name for them. So yeah, what we need to do. So first of all, we need to build that roof. So what I want to do, I'm going to be using reference planes. You can find them over here. It's just for draw a roof. Let's name this A. It doesn't that matter. So you go to the south elevation and you just go to architecture, and here go to roof and roof by extrusion. So now we can pick a plane. It's going to be my reference plane A, and I can pick level 2. It doesn't that matter, and we can build some sort of arc, something like this. It doesn't matter the way, just something like this. So if I go to 3D, this is what we have, right? We can change this to maybe square. Yeah, that looks better. So we have this geometry, right? So now we need to go to Dynamo. So let's go to Manage and go to Dynamo. Let's wait for a minute. And I'm gonna go like back and forth to the presentation so you can understand each step, so you can comprehend the information better. So let's go to New. So yeah, first things first is that if I go back to the presentation, we need to pick the face of the roof, right? I can go with the select face node, select face. So what it does is that when you select it, you'll go to the Revit interface, right? And you can actually pick that face. So the face of the roof, and basically face will give you a surface. And now we can do some manipulations with the surface. So first of all, we can get normals of a surface, and I'll visualize everything. So as I did over here. So for example, you will see these lines actually, so you can understand, because when you're creating a vector is something that is abstract. You cannot see this. but we will visualize this to understand this better, to improve the comprehension of this. So let's go back to Dynamo and go with the normal add parameter, for example, right? Normal add parameter. Here you can have the node for the surface. So when I'm connecting the surface over here, I have U and V direction. So first of all, even before because we've picked the surface, actually that should have been there, element.geometry, or that wants us to actually, no. So basically that should have been there. Oh yeah, okay, I messed up a little bit. So there we go, we have a surface, right? So we have surface normal add parameter, so we can get some conditions like from 0 to, so we have U and V values, and the minimum value is 0 and the maximum value is 1. So what I'm doing here is that I'm creating a sequence. So from 0 to 1 with the set step of with the set amount of items. So for example, I can create slider, integer slider, and I can create like 25. So what that will create is that numbers that will go from 0. So 0 is my first number, 1 is my last number, and I'm setting how many of these I would like to have. And this one will determine the quantity of beams. You can also go with the surface like point add parameter. Why? To understand actually which direction is correct. So we can use this just to understand which direction we actually need to use. So actually, yeah, and here it gets only 1 point. So you need to go and make this one like cross product or like lacing. The longest lacing will work also. So as you can see here, what we have is that we've got the points and the V direction is the correct direction. So this is the normal. So I'm gonna get like vectors. And again, and if you think about this, why that works that way, so it takes one surface, right, and it goes right to one element. So even if I go to longest lacing, that will go through all of them. If you're not familiar with lacing, that just takes one surface. So basically what it does, it takes one that sees that list and that sees that list. As you can see, we have levels over here. That takes this surface and connects this to 0, right? And this is, we're getting vector on the 0, and that stops. So by saying longest, right, by going right click and going to the lacing and setting this to longest, it will actually it will make sure that this one surface will go through all of the elements. So it will go like surface to the 0, surface to this number, surface to this number, and that will give you vectors. Now the main question is how we can visualize them. Actually, yeah, we should go back this surface point add parameter. Surface point add parameter, surface, and that is the parameter, right? For some reason, again, lacing to longest, right? There we go. So we have an amazing node that is called line by start point, direction, and length. So basically this will be my start point, right? The direction is these vectors, right? And we can create something like go with 2000 as the length. It's just to visualize this. As you can see where these vectors are pointing, this is the perpendicular lines. This is exactly what we would like to get here. Now I would like to show you something else, that we can even get these that we can get like curves out of our surface. So when you have a surface and you use some node that is called get isoline, so you can pick a surface, you can feed that into that node, and here you can go to the parameter. And if you set this parameter, again, you need to go to the lacing and longest. As you can see what it does, it creates curves along your face. So we can change also the direction. It also has just two directions, either 0 or 1. By default we have 0 that is running in this direction. If you were to click like 1, it will go like in this direction, but we need to have like 0. So we will do with the default value. Why am I doing this? Because first of all, the first reason why I'm choosing to go with this curves, because we can create structural framing based on the curve. But the second thing is that we can go with the curve, point at parameter, and we can take this, actually not point at parameter, but normal at parameter, curve dot normal at parameter. So what it does, it will give us some vectors, right? So I'm connecting that curve and I'm getting the same amount of vectors, right? And let's try to visualize them, right? Let's connect the vector to this. As you can see what we have, if I go back to the presentation, this is exactly what we have. So we have two vectors, one goes in this direction and the second one goes in this direction. So this is exactly what we want. So basically we have two vectors that now we can compare them. So we have two vectors to compare. To compare vectors, actually you can also work with this. I'm just used to working like this in the search bar, but you can go to geometry, abstract, vectors, and here you have all of the options like how you can modify vectors. And here I have an amazing node called angle with vector, which actually waits for two vectors. So we can have this vector and this one. And what you get is the angles. But if you remember what I've told you, that we get this vector, this angle 34, right? This is the angle that we get. But we need to have this one. If I go up, this is exactly what we're aiming for. So now we get this angle and we need to have this one. So to get this angle, you need to subtract this value from 90 degrees. So what we can do is that, let's go back to Dynamo and let's just go 90 from A, for example, right? And you can connect this one. To understand whether it works, is you can even see that the first angle and the last angle should be kind of the same, but this one should be negative. So now we can actually delete these lines. That one was just for visualization, right? So it's easier for you to understand how that works. So once we've created this part, I would like to go to manual mode, because what we're going to do over here is that now we've got the angles. So let's kind of make this that way. So let's say that we can even group this or not. You can even group this. It's better to actually, of course, to kind of organize your script. You can connect this, hit Control G and say, like something get angles, right? Then we have a node that creates a structural framing, right? So we go structural framing. Beam by curve is actually what I want to create. So here I've got these isolines. As you can see, I can create this to the curve. I can type here like framing. I can type framing, structural framing types, and I can connect them to the structural framing. And I also need to have a level. It doesn't matter what level you pick, it just needs for the input. Let's pick like the second or the first one, doesn't that matter. Why I went to the manual mode? Because actually what we want to do is to change these parameters. So our goal is to take each beam. So if I were to draw a beam over here and go to view range or go to 3D, okay. I want for each of this change this parameter. So I can go back to Dynamo. I can go set parameter value by name, right? Set parameter by name. I can pick all of the structural framing that I'll create, and I'll pick this parameter. I hope I'll spell this right. So cross section rotation. The case matters, right? So make sure that you follow the same name, right? I think I did so, right? So let's go back to Dynamo. So that'll be my parameter name. Oops. and these are my values, right? These are my values. So right now when I'm gonna play this one, actually let's delete this part. So now we can go with run. So there you go, you have this thing, right? So basically we have a roof. You can change if that one will go in the automatic, so now you can make this longer, right? Everything will follow this. You can make this part, everything will follow this. You can go and change the quantity of beams, like 15, and as you can see, everything will work smoothly. And basically, yeah, this is what we were aiming for. So yeah guys, that's it for this lesson. I hope that was a useful tutorial in learning about creation of structural framing with the help of Dynamo. Thank you guys for watching this video up to the very end. If you're not yet subscribed to this channel, hit the red button down below, and I'll see you soon in my next video.